Okay, and I think I'm live as of right now. So let's start. I've switched around a lot of things. Hopefully the sound will be much better. I am using OBS now to stream, so hopefully everything will be cool. So if anyone is watching this or will be watching this afterwards, the recording, let me know if this actually looks okay. So in the previous session, I basically wrote a very basic Sudoku solver. It was just a very pure backtracking solver, just making guesses and then checking if the guess is wrong. And well, that part is done as of right now. Of course, it's very messy, so we need to clean it up. But basically, we have a functional Sudoku solver. So let me just write this down. This is done. So there are a couple of things I wrote down at the end of last session as things that we might want to do. So let me just scroll through this quickly. So right now, a lot of the things in the code are hard-coded. So I really would like to unhard-code some of the things. Right now, the solution for the backtracking solver is a recursive one. So I would really like to change that into a non-recursive solution using a stack. For 9x9 Sudoku, this is not really an issue, but if we ever try to do more complicated things, we might run into Stack Overflow. We might run out of stack. We definitely should write some tests. So right now, this is very simple. I can just basically, test in my main if the Sudoku solver is working. But the moment I start doing more fancier things, this will become an issue. And overall cleanup of the code related to the hard-coded thing. So I definitely want to have an easy way to just print out the Sudoku in like a reasonably nice way, even in a text mode. And right now, the way we check if a Sudoku is correct is not particularly clean. So yeah, that's another thing that kind of needs cleaning up and improving. So I think I will just start with the cleanup first. And actually, let's just start with cleaning up the checker. So this function here, all it does, it just tells us whether Sudoku is valid. Now we do it in a very silly way. So we go over all the rows, we check if, for each of them, if we have any collisions, which is basically what tells us whether the Sudoku is valid. What is a collision? Well, we have the same number multiple times in a row. And then we do the same thing for columns, and then we do the same thing for the 3x3 blocks. So as you might see, these kind of look very similar. We always have this vector of booleans that, we note whether we have seen a particular number, and then we basically do the same thing inside of these blocks. So we just check whether we have already seen that number, and if we did, that means we have a collision, and just return false. And if we didn't, we just mark it as, okay, we have seen this number now. And we do the same thing for the columns, and we just do exactly the same thing for the rows as well. So this is definitely a place where we could do a little bit of code reuse. So let me clean this up a bit. Now the tricky part here is we want to have a good way to basically initialize a block checker essentially. And to make this flexible, let's just say like the block can be anything. And I mean, as an example, there are Sudoku puzzles that have 2 additional block constraints, and that's the diagonals. So we kind of want to have a way to just have a block checker that just gets like a bunch of elements from the Sudoku. And let's just assume that now that the number of the elements is, always the size of the Sudoku to make things simple. So if you have 9 by 9 Sudoku, the block size will be always 9. But if it gets a block, it shouldn't really care about the shape of the block as such. So we kind of want, let's just start jotting this down. So we want a block checker, and the block checker will need to be initialized with, now the question is what exactly. So I will need references to the elements in the Sudoku. So the easiest way to do that would just be I get vector of pointers. So this will be the elements the block checker will be checking. I guess this is okay. Yeah, let's just do this for now. Okay. So if we do this, then we need to store it somehow. So let's just make this a private attribute, and let's just initialize it very simple way. And I guess at this point this can just be its reference. So then we definitely need the function that actually runs the check. And this one will actually go and check whether we have a collision. And I guess I can just very quickly implement this one, because this will be just a copy paste from here. So we go over our elements. If we have, if the element is not set yet, we just continue. If we have seen the element, then we just return false, and otherwise we just mark the element as seen. Okay. And if we go through this method without encountering a collision, we just return true. Right. I guess that's kind of enough for this piece of code, because we don't particularly need anything more here. I think, yeah, this is enough. So now what we need in our Sudoku class is to actually have a way to remember these block checkers. So let's just write this down. So the basic Sudoku, we have rows, we have columns, and we have blocks. 3 by 3, basic Sudoku of 9 by 9. So then for diagonal Sudoku, we would have the 2 diagonals as extra. So do we just want to have this as part of the constructor and just tell the Sudoku what type of rules we are working with? I mean, that would be one option. I've got to put public here. Okay, I guess that's fine. So let's just do Sudoku types, and we'll have basic, and we will have diagonal. That should be good enough for now. So then the constructor of Sudoku will take the type of the Sudoku, and then in the constructor we need to set up our block checkers. And okay, this is getting a little bit too big for the main, so let's just split it out. Let me just split this up. So this goes into the header, and the implementation needs to go into the CPP file. Okay, and then I can clean up the header a little bit. Like this, okay. So now I can delete this from here. And I will also create files for the group class. And put this into the header. And then I guess there isn't really much to put into the CPP file. Let's just clean this up. So this is our data. This will go into the CPP file. And I guess we should also do, if you are doing a type of Sudoku, I guess we should also do size of Sudoku. And we can just default to size 9 and basic. So this needs to go here as well. Okay, so the initialization then needs to be size and size. And now here we need to actually initialize our checkers. So I need the block checker header. So for each row, I will need to create a new block checker that will represent the row. So Right. I will need a temporary vector here that will point to the elements of the row. And then I just go over the elements of the row. And yes, like for now, I will just do square Sudokus. We can revisit like weirdly shaped Sudokus eventually. But for now, let's just do the square ones. Okie dokie. So here I just want to get the element and put it into the vector. And I want its address. And once I have this, I want to create a new block checker. And what? Okay, there's something weird going on. Why doesn't it see the vector? Okay, maybe because I'm missing the vector here. That would kind of make sense. Let's go back here. No, here. So block checker. Okay, now it sees the constructor. Okay. But I need a way to store them. So actually, I want another vector here of block checkers. And this will be, yeah, right. And I just add it into the array of my block checkers. So I do this for the rows. I do the same thing for the columns. And I do the same thing for the blocks of 3. And actually, I'm just realizing I can just take the code I already have from here and kind of just reuse it. Except this thing to be vector. Okay. So this should be good enough for the basic Sudoku. And if we have the type basic, At this point we are done. But if not, then we also want to go over the diagonals, and we have two diagonals. And I'm just realizing I really don't like the 3 here. But does C++ have a square root that's working on integers? I don't think so. I think the basic square root double complex, yeah. And that's unfortunate. Okay, let's just leave it like this for now. I will need to fix it later. Because this gets slightly tricky. So for 9 by 9. Oh yeah, I just noticed someone is actually watching. Thanks for the comments. Yes, I could use mplace back. That's actually a good point. For this one, would it actually help? Yes, it would, because I have a vector inside of the object. Yes, indeed. That's a good point. Oh, what's the problem here? Why doesn't it want to autocomplete for me? Oh, because, of course, the header should be here. Because it doesn't understand block checker otherwise. And now I can move it from here. Right. Now it should work. Yes. Oops. And the same here. Okay. Yeah, okay, let's revisit the number 3 later. For the diagonals, we basically want the same thing again. Oh, actually, no. So we only have 2 diagonals, so we want to do one diagonal like this. And actually, we can just do both of them at the same time. Right. So for the first diagonal, we want to put in pointer to data I. And for the second diagonal, we want to put in the pointer to the data I, and the column will be on the opposite side, so size -1 minus I. And place back for D1 and D2. Okay. So this way we should have all the block checkers set up correctly. So let's just try to do this. I did one thing that kind of broke my main, so let me just, so I can test it quickly, I'll just make this into public for a little bit. Why is this? Oh, I need to include my new headers. And okay, let me just revert the rename for a bit so I don't have to go around and change everything again. So now the check puzzle, this is the piece of code I really want to change. So instead of doing this thing, I want to actually go to my Sudoku and have a check puzzle here. And the check puzzle here will actually just loop over my checks. This should be CEST. And if the check is wrong, then just return false. Otherwise, return true after we have looped over all the checks. And I guess I can just rewrite this into okay. So this should now check the entire Sudoku puzzle for validity. So if I replace, where is this actually called? Here, okay. So instead of this, I want to do dot check puzzle, and the same here. So this way, this code should still work just fine. So let's see. Oops, actually it won't, because we are initializing this in a very stupid way. Okay. I guess there's no trivial way for me to fix this. Yes, STD all would also work. I'm keeping the pointers to the elements, so I cannot just overwrite the vector here. Okay, let me just write a new constructor then. That will just take the and sure. In this case, I can achieve this here, and then like this. Okay, so now I have a constructor that actually constructs from a vector. Yup, that's okay. So in this case, I can just do this and then initialize my Sudoku from the data. Yes, I do know the dimensions compile time, but I actually don't want to use an STD array for now. So this gets a little bit complicated. Normally Sudokus are 9 by 9, yes. But I want this to work for differently shaped Sudokus as well. So I at least want this to work for 16 by 16. That would still be okay with using std array. I could just basically instantiate like two versions of the template. But it gets really awkward really fast because the templates kind of propagate through stuff. We might eventually change it to an std array. We will see. For now, I just want to keep it as a vector to have the flexibility of playing with things. But yes, like I'm right now, I'm definitely not at the point where I want to optimize things. Okay, let's see. What's the problem? Okay, yeah, I changed this thing again, didn't I? Ah, why do I keep doing this to myself? Okay, let's revert it back for a bit so I can just run this finally and see if this works. Uh, what is it actually complaining about? Undefined reference to check puzzle. Uh, oh, okay. It didn't update this file, that's weird. Uh, yeah, we will get to optimizing things around, don't worry, eventually. Uh, where do I have data? Oh no. Okay, I will need to. Okay, let's bite the bullet and actually make the code proper. So this goes here, and here. I will just write. Okay, so in CMake you don't have to add a header. I have more experience with Bazel than CMake, but yeah, might not be needed. Um, so here I want. Oh, can I do? I will just be lazy and do it this way for now. Okay, this will all get cleaned up eventually. But for now, let's just want to see if it's work. I technically don't need this code anymore, so let me just copy this out. It should be all. Still not happy. Oh yes, okay. But we are getting there. Where is this happening? Oh. Uh, is it comparing exactly as this argument discards qualifiers? Because check should be definitely a const method, right? Because it definitely doesn't mutate any state. Right. Couple more places where I have the alt access. And couple more places, of course. Okay. Okay, it compiles and it runs, but that doesn't look correct. There's way too many ones in Sudoku. Okay, this actually looks like it always returns true. Just looking at it. Yep, it definitely does always return true. So, but it seems to correctly pass in the data, so that part is okay. So where did we make a mistake? So check puzzle. If a check fails, then I return false. Otherwise, after I've gone through all the checks, I return true. Okay. And here, if the element is 0, then I just continue because that one is not initialized. If I have already seen the element, wait, is this just priority issue with the... I suspect it is. I might be wrong, but let's just test this. Nope, that was not it. Okay, this is pretty strange. Let's just see what happens if I run it in debug. Wait, what? Why did it not catch on the breakpoint? Oh, does it even code this code? Somehow it doesn't. What the heck? Okay. So it definitely does catch on this piece of code. Oh yes, okay. Because I no, I'm such a moron sometimes. Okay. Well, I created a new constructor that doesn't actually set up the checkers at all. So yes, that's where my problem is coming from. Right. I guess the easiest thing will be just to move this code into a new method. Right. Let's just make a private method. I do need to know the size and the type. Okay. Let's just move this entire piece of code into here. Then in here, I can just call it. And I can do the same in the other constructor, which I should actually move into here as well. So here actually my size will be data.size and the type will be type. Right. Okay. Now I can clean this up. And technically, what's this component? This declaration. Ah, yes. Okay. Um, that does look better, but it's still wrong. I mean, obviously, just even looking at the first line, this is not a valid Sudoku. Uh, but it's doing something. It means there's some bug in my setup. This is very interesting. Okay, now I want to see what the heck is happening in the check routine, because this is pretty strange. So I do have 9 elements. And it seems they are unique elements and they are 4 from each other, so they're correctly pointed. This would be the first row. Kind of makes sense. So this part seems correct. I mean, this seems to be doing stuff. So what do we actually have in this array? Right, so I'm not sure if you can actually see it on the stream because it's... I actually don't know how to increase the font of like font in the 2 windows, unfortunately. I wish I knew how to do that. But okay, so we have a 1, a 2, 3, and a 6. So we have already noted the 1, the 6, and a 2 and a 3. So this does look okay to me. Like, I don't really see anything obviously wrong here. And in the check puzzle, I just go over all my checks. Hmm, very interesting. I don't particularly see anything obvious happening. But the good thing is, since we kept the old code, we can kind of do comparison of the old code against the new code and see what the heck did we break. So, right, let's just do that. Okay, so let me just quickly modify this code. Actually, let's just do a find and replace. And it's thank you. So how do you do find and replace? Ah, submenu, of course. So I want to find Sudoku.data and I want to replace it with Sudoku.data call. And yep. Okay. So now I have the old piece of code and the new piece of code. So now what I want to do is in here, basically if I do this, I want to do, if these two don't agree, there is something wrong. And yeah, I guess that's it. And at that point, I want to just print out the Sudoku, I guess, which is a good opportunity to actually write an output operator here. Oh, what the heck was the signature of an output iterator? Output operator. Hmm. Da-da-da-da. Right. We return on a stream and we take an off stream. So just quickly copy the code from the main. And here, I don't want to put it on COD, I want to put it into my stream. Yep. Let's see if this works. Here I actually need the proper. Alright, this needs to be a friend, not this needs to be a function, not a method. Right. And uh, okay, let's try this again. Okay, so we have an output and we can now go back to this piece of code and do this. And I guess I want to also print out the actual values. Yep, okay. So we definitely have a problem. Um, okay. I will take a 5-minute break to think about this and I will be right back. See you in 5 minutes. So, one thing I noticed is this thing is actually not ending with a 0. It's ending with an exit code 139, which is very strange and suspicious. Can I actually run this? Yes, I can run it with memcheck. Oh, what? Didn't find Valgrind? How is that possible? No. That's annoying. I don't think this will straight up work. Hmm. So yeah, because of the way I have this set up. Two chains, yes. But yeah, that doesn't include Valgrind, and I don't think I can have Valgrind. From the Linux subsystem. Okay. Hmm. Yeah, there's definitely a situation where our new checkers are just not checking well enough. Actually, oh, it does crash. What the heck? Wait, it crashes when it's printing out? That's interesting. Ah, and this is also quite interesting because looking at the somehow we have only 9 block checkers, which is strange because we should have 1 per row, 1 per column, 1 per block, which is already 27. And then if we have diagonals, then we have 2 extra. And we also crash if we try to print out our data, which is very curious because, I mean, we just loop over the vectors. We just corrupting our memory somewhere. Oh, it's so annoying that I cannot just run my Valgrind because that would immediately tell me what the heck is wrong. Okay. I mean, okay, that I doubt there's anything wrong with this particular piece of code because, I mean, I just get the data. This just gives me a const reference, and then I just access. Yeah, I don't think the problem is in this piece of code. How would we end up with only 9 block checkers? That's a very interesting question. And the thing is, these look it kind of look like they're rows, but not really actually. Just looking at the pointers. Okay, there's something very funky going on here. What the heck? Ah. Was that it? Wow. Okay. Foiled by an STD move. Okay. It's an interesting bug to run into. Okay, so if you didn't catch that, basically what was happening, since I refactored the setup checkers into a basically a subroutine, it would work fine, except I put in the data size here. But when this line gets executed, this piece of code already happened. So at this point, what's inside of data actually, well, I'm actually not sure how this is defined for vector, but basically, if you move out of a variable, you kind of can have an issue because each type can kind of define by itself what the hell happens when you move out of a variable. And technically, the data that was in the vector array is no longer in the vector because this has been already moved out into our new vector. Since I was still referring to the old vector, that's where the bug got introduced, and then that's why it was also crashing. I think it's still crashing. What the heck? But it works at least. Is it still crashing though? It's still crashing. What the heck is it crashing? That's so strange. But yes, we have the 27 correct. Okay. This is very interesting. Um, Let me just try. Oh, okay. Here is the actually the project. Okay, so user. Let me just try to run this from the Ubuntu directly. And yep, I do have Valgrind. This should work. Maybe not. Okay, so what seems to be the issue? We seem to be printing a null pointer. Um, that is very interesting. Ah, yes, because as usually it's a very stupid error that I did because I kind of forgot to do the obvious thing. I need to return. Yes, and now it doesn't crash anymore. Okay, good. So I guess all the mysteries are solved, at least for now. Cool. So we managed to. I don't need this weird binary. Ah, I'll do it later. Okay. So we don't need this piece of code anymore at all. We can just get rid of it. Technically, we support diagonal Sudokus at this point, but I'm actually not sure if this does. Yeah, this already violates the diagonal constraints because we have 2 and 2 on the diagonal. So this is not a good entry for a diagonal Sudoku, but I guess I can just quickly Google for a diagonal Sudoku to just see if that works. Okay, so here is a random website with some diagonal Sudoku that looks. Okay. I don't know if they have a solution here actually, but let's just see. Okay. I want. Can you keep tabs on top in Windows? I don't know how to do that. Anyway, let me just put it to the side. So, 3, 0. Okay. Then here goes a 9. 6 and a 4. An 8. 9. Okay, then a 3. And 8. I think. And 1. The zeros, here goes a 9. Okay. 0. And 6. 4. No, it's the wrong line. Okay, like this. 2 and the last row. It goes here and then. Okay, so this puzzle should be solvable as a diagonal Sudoku. So if we do test 2 diagonal, oops, data 2, we can try to solve it. And then we can try to print it out, and it should solve and it should print out just fine. Let me just put a divider in between, so we know where one puzzle stops and the other one ends. What's wrong? Oh yeah, I removed the old function, so makes sense that you are complaining. Yep, we don't need this anymore. Okay. So let's see, does this... I'm just quickly checking if this makes sense. Yes, indeed, this does look correctly solved, at least to me. Yep. Cool, okay. So we have the block checkers. So let me go to my to-do list. So what to do is we want to do? We wanted to do an Austrian operator. We have that. Yep, this is done. Well, we didn't really unhardcode things enough. Okay. So version 1, we have version 1. We can solve Sudokus and diagonal Sudokus. And actually the thing I wanted to try and see is, can we get a 16 by 16 Sudoku? Let me quickly Google for 16 by 16 Sudoku. Okay. So just for an idea, this is how it looks. And we will actually need to fix our crap in the initialization of the Sudoku puzzle, because there we now assume that we have 3 by 3 blocks. But for 16 by 16 Sudoku, you actually have 4 by 4 blocks, which changes things, of course. So yes. Mm, I mean, okay, we can just do it the stupid way for now. Because I don't like square root works on top of doubles and floats. I mean, you can square root an integral type, but it still returns a double, which is annoying because then we need to do like rounding and crap, which I'm not really. It's not really something I want to do. But technically, we can just have a very simple very simple thing here that just does the mapping of the block sizes. I mean, okay. Okay, will this actually work? I've never tried initializing a map like this. Well, maybe it might, but we need the includes. Okay, build it. Okay, looks like this will actually work. Okay. So what we want is block sizes, size, yes. Sizes, size, and then actually, let's just do a shortcut here because I don't want to keep writing block size. Let me just do B size. And I'm just like, this should be true, but I'm very much hoping that there isn't a Sudoku type where the number of blocks differs from the block size. It shouldn't be the case because inherently, like within each block, be it, a row, column, or an actual block, you want to have the number of elements. So kind of inherently you need to have block sizes that are square root of like the number of elements in a row. But I still remember, like, I have seen some weird Sudoku puzzles that were like 6 by something, and they also had pretty weird block sizes inside. But let's just hope this works. So that should be the only thing that was hard-coded for the size. So this actually should be pretty unhard-coded as of right now. So sure, we can remove that, and let's just then see if if I actually copy this crazy thing, does it actually solve it? Or does like my stack explode or something other and weird happens? But yes, this will probably take me a while to write down because this is a big Sudoku. Okie dokie, so we need each of the lines now. And I will need 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of them. Okay. So I should leave 2 spaces for things because we go up to 15. Oh geez, this will be hard to not make a mistake. So I have 15. No, crap, that's actually a 16. Ugh. Then I need 4 zeros. Then a 15. 14. A 0. And a 2. Then a 0. 6. 0. And what the heck is that? That's 13. Yes. Ooh, okay. So then beneath that I have 0, 0, 0, 0. Then I have 3, 2, 0, 0. And 5, 0, 0, 0. Then 0, 0. 10 and 14. Okay. Then 0 and 8. I'm starting to wonder if there is like a standard Sudoku format that already exists. That would be so neat, and it probably does exist. I just haven't been smart enough to look it up. G is a 16, then a 6, then we have a 0, a C, which is a 12, yes, a 3 and a 0. Then we have an A, which is a 10. Then we have a bunch of zeros. 3, 2, 3. And here goes 14. Then a 12. 7, 3, 0, a 5, 0, 1, and 0. Okay. Okay, 0, 0, 0. Then 5, 6, 16, 2, 3. Oh, no. What? Where am I? This should be a 15, not a 16. Oh, I'm already making mistakes. This is bad. And this actually should be a 0 and then a 3. Oh, copying this by hand is really not a great idea. 615 to space, yes. Then a 16 here, indeed. Then a 0, then an 8, then a 0, then a 9, 0, and a 0. Okay. So that's a 12. 3, 8. That's a 10. Then a 0. And a 16. Yep, seems to be lining up correctly. And 4 zeros, then a 2, and 11, and 2 zeros. Okay. Jeez. This is much harder than just the actual coding part of the thing. So what the heck is a D? That's 13. And a B is 11. Then 2, 0, 0. F is 14. Then 0, 0, 0, 10. Whew, okay. 6, 0, 0, 0, 5, 0, 0, 0, 0, 0, 1, 0, 4. That's 14 and 0. Okay. Whew, halfway there. Okay. Okay. 2, 3, 0, 7, 3. That's 14. Then 3 zeros. That's 7, 3 zeros. Okay. Then 6 and 3 zeros. And E is 14. Something's wrong somewhere. Crap. Oh yeah, I skipped one line. Yes, okay. Things were not lining up. That's because I managed to skip a line. Okay. 16 and then 8 underneath 3. Yes, that works. 6, 0, 0, 0, 15, and then 0. And now we are back here. Yep, now it makes sense. 9, 0, 0, 0, 4, 0, 0, 16, 0, 0. Yep. And then 0, 0, and 8, 0, 0, 7, 0, 10, 0, 2, 0, 0. Yep. Then a 0. That's a 14. That's an 11. 1. Okay, finally the last 4 rows. So an 8, 0, 0, 0. What the heck is a D? That's a 13. Is it? Yes. It's 10, 7, 0, and 4 zeros. Yep. And 16 and 3 zeros. Yep. Almost there. 1, 2, 3, 4. Yep. 4. Then 2 zeros. 7, 10. 13, indeed. 0. 9. Alignment is broken a little bit here, like that. Yes, that's the correct alignment. 9, then 0, then 8, and then 11. Okay. And the last 2 rows. 9, 1, 0, 2, 0, 12, 0, 0, 0, 0, 0, 4, 0. Okay. This is 0, 0. E is 14. 10, 3 zeros. Yep, that's lining up. 11, 15, 3 zeros, and 4. Then 10, 2 zeros, and 5. Okay, so we have a 16 by 16 Sudoku. So let's see what breaks. And we just want a basic Sudoku, we don't want a diagonal one. Yep, the 3. We want to solve it. Yep. And then we want to print it out, of course. Okay, build it. Something's wrong. Invalid type. Oh, yes, that shouldn't be its size. Of course not. Build. Okay, let's see if stuff explodes. Oh, stuff didn't explode, which is neat, but it prints it out in a completely... Oh, no, something is wrong. It didn't solve anything. Did we actually solve the correct? What the heck happened? I mean, it tried to solve it. I guess it failed at solving it, which would mean that I made a mistake writing this thing down somewhere. That's annoying. And I already see one more thing that I want to do. So in our Sudoku printing thing, we kind of want to set the width. Da, 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 da. Yeah, I guess for now. Oh, what was the name of this thing? Is it set W? Yes. Okay. So if you are printing out the puzzle, I'll just do it in this very ugly way for now. So we set the width to 2, in which case we don't really need this part of the thing. And if it's bigger than 9, so 10 and more, which means we will need basically 2 spaces and then 1 extra space for the division between the elements. Let's just set the width to 2. This should work. Of course, it's not puzzle.size, it's puzzle.data. That size. And I need the correct include for this thing, of course. Okay, so yep, now it prints out things in a pretty way. But it still doesn't work, which is really annoying. Yeah, it's print one of the solves failed, and it's quite obvious which one. So yes, there are 2 options. Like either I made a mistake copying the puzzle, which is definitely possible, and I basically made it unsolvable, or we have a bug somewhere. But yeah, we have been going for more than 1.5 hours already. So I think I will leave that as a thing to solve next time. So let's just go over what we actually did. So we have the version 1. We can solve Sudokus, diagonal Sudokus, and maybe 16 by 16 Sudokus. Maybe, who knows? We don't really have much hardcoding things anymore, but potential next steps is we might want to do the stack-based non-recursive solution, although the more I'm thinking about it, the less I'm super convinced that it will be actually needed. Like, we still might want to do it, but maybe it's not too important. We definitely want to write tests because we had some interesting problems we ran into today. So if I had unit tests, that would kind of help me debugging the things easier. We definitely want to fix the access to the elements of the puzzle. Because right now we kind of do the stupid get me the data and then just like walk over the data, which is not particularly great. So we basically want to have like get me a thing at coordinates or actually have operator square brackets. Since I'm doing this kind of craziness, I will try to look up data format for Sudokus if there is any. It should be super useful because if we can actually read like some already established data format, we wouldn't have to deal with this crap of like manually copying the Sudokus, which is really tedious and annoying. And especially if there is a format that not just has the input but also has the solution, that would make testing our solver so much easier. And I guess right now the solver itself is just like loose functions. So we should encapsulate the solver into a neater package. I guess, I mean, a class. We should think about like what exactly, like if, so this, so far we still have the very basic solver, which is very stupid and it's just basically guessing and backtracking if it guesses wrong, which works for now. And I'm actually surprised like how performant it is, just even on the 16 by 16. Like, I mean, if I run it, like it does check for like there's definitely like a while before it returns the solution for the 16 by 16. That's in particular because it actually does like backtrack back to an empty Sudoku. So it really goes through like all the possibilities it can. It really tries hard to actually make it solved. So for an actual Sudoku that can be solved, it will be slightly faster, but like for my purposes where I actually want to have this like eventually, this is a little bit slow. I want something that's really interactive. I really don't want to have this situation where it like chugs for a bit and I kind of, yeah, I really want to have something that will work in a very interactive way. So it needs to be blazingly fast, even on 16 by 16. And considering I want to throw at it much more complicated things than just like basic Sudoku, that have a lot more constraints and more interesting things, where it will need to go through a lot more code to actually get to the solution, we will definitely need a more complicated solver than just this backtracking one. And in particular, for my original goal, where if I go back up, I want to have a generator that actually understands how humans solve Sudokus, so it can provide difficulty ratings and so on. Like, I kind of need a solver that includes the essential approaches that people use when they're solving Sudokus, right? So there are kind of these mini algorithms that people use when they're solving Sudokus. So I kind of want to re-implement that in my solver, because if I basically give it an input Sudoku, I kind of want to get back like, okay, like for this Sudoku, it was enough for me just to use like the very basic algorithm, you know, finding naked singles and hidden singles. So if that's enough, then obviously like that's a very basic approach to solving Sudokus. Like you can just do it, you don't really have to think about it. So that's a very easy Sudoku. If you kind of need to do doubles and triples and X-wings and whatnot. Like, I kind of want to get a rating of like how complicated of an approach the solver needed to use to actually get to the solution. And obviously, the current one is just guessing, which is like kind of the opposite of what you should be doing with a Sudoku. Like, a valid Sudoku should basically never need you to guess. Like, there are some puzzles that kind of need you to like go do a bit of a backtracking. Like, you kind of need to bifurcate and like test one path, and then you realize like, okay, like that's a nonsense, and you just go the other way. But like, it's an approach you can use, but I don't think that good Sudokus have that in them. So I kind of want to. We really need to go to the human approach to solving Sudokus if we kind of want to generate good puzzles. Because if I would basically use this solver that just like brute forces everything to generate Sudokus, I can very easily end up with Sudokus that really need you to basically do the backtracking approach, because that's really like none of the basic algorithms that people use to solve Sudokus actually work. So we will definitely need another solver. So we will need to think about what should be the interfaces exactly, and if we need to actually change the way we represent Sudokus, because right now we just have an array of numbers, and that's our Sudoku puzzle. Well, if you look online at like how you solve a Sudoku, that's not like what people do. You basically pencil mark things. So you kind of go around and say, okay, like this particle space in the Sudoku puzzle can contain 1 or 2, and that particle space can contain a 3 or a 4. So instead of just having one number, you kind of have basically booleans for all the numbers that can be in each of the spaces, and you kind of go and eliminate the possibilities. And that's a very different data structure than what we have here. So next time we will definitely want to think about like, when do we want to switch our data structures from just like a basic array, which works great for now for our very basic backtracking solver. But if we actually want to mimic the human solutions, we will need a different data structure to do that. And that will definitely take a little bit of design. Okay. Right. Not new data structure, new puzzle data representation. Okay. Right. So I will offline check if I manage to break this puzzle somehow, or if there is actually a bug in our solver that doesn't work for the 16 by 16. I do hope it's just me breaking the stuff, because yeah, I don't really see what could be actually wrong with the code. But yeah, I think that's enough for today. I do expect to stream again next weekend. I think I will try to keep to like the at most 2-hour sessions, because otherwise it just gets crazy and I get tired, I make mistakes, and it's also impossible to watch afterwards anyway. So So yep, if you were watching, thanks for joining. If you are watching the recording, then thanks for watching the recording. Feel free to ping me for any questions you have. And yeah, see you at some other time watching the stream, perhaps. Bye.